Welcome to the subject EMTL, Electromagnetic Waves and Transmission Lines. This course is for second year, second semester for the branch Electronics and Communication Engineering. So, myself Dr. Ramakrishna Sharma, I am the faculty for this EMTL subject for this semester. So, before going to the subject, I will just want to give a brief introduction for this subject EMTL. So, this EMTL subject, it consists of two modules. The entire subject is categorized into two modules, I can say. The first module deals with what is called as EM, electromagnetic fields, and second module which captures TL, transmission lines. Now, the syllabus, you have first three chapters, unit 1, 2, 3 under EM theory, and last two chapters 4 and 5 for transmission lines. Now, what does EM consist of, or EM fields consist of? See, electromagnetic field theory, which comes under the field theory, the study of electric fields and magnetic fields, comes under field theory of the subject. Now, what is this field theory? Field theory deals with the propagation of electromagnetic waves which are used in wireless communications, because the entire communication engineering is broadly classified into wired communication and wireless communication. If you are using a medium, a wire, to send the signals, that is called wired communication. The signals are electric signals there. However, in field theory, the signals are electromagnetic waves, which inherently consists of electromagnetic fields. They do not require any medium to propagate, which means you do not need a cable, you do not need a wire to transmit these EM waves. They can propagate by themselves, because electric field and magnetic fields are forms of energy, and these energies propagate in the form of waves. So, we alternatively use the terms transportation of electromagnetic energy or propagation of EM waves. We use these terms alternatively depending on the scenario. Since these waves propagate, having that energy, these waves propagate, they carry some information along with them from one point to another point. Here one point means from a transmitting station to another point means to a receiving station, without the help of any physical medium, without the help of wires. Hence we say wireless communications. So, by this discussion you understand that the study of electromagnetic fields forms the basis for modern wireless communications. So, EM field theory is the backbone for wireless communications. Then, what is backbone for this EM theory? There are four equations, revolutionized equations, which was proposed by James Clerk Maxwell, which are known as Maxwell's equations. So, the relationship between this electric and magnetic fields as they propagate from one point to another point, the relationship existing between the fields is given by the set of four equations which we name as Maxwell's equations. Maxwell's equations describe the relationship between the two fields, namely electric and magnetic fields, which are time varying in nature as they propagate from one place to another place. So, Maxwell's equations are the backbone for, we will write here, Maxwell's equations are the backbone for EM theory, and EM theory is the backbone for wireless communications. So, this is the hierarchy that we follow. Being an EC graduate, Electronics and Communication Engineering graduate, which we have the component, the second component as communication engineering, it is very important and fundamental to know the mechanisms of these EM fields, and there are three chapters dedicated for this study. First, second and third chapters totally dedicated for this study of EM fields. We say EM theory. Next comes the second module of the subject, which is TL, which stands for transmission lines. The study of transmission lines is nothing but line theory. So, what does these lines do? The lines carry the signals. it is a line, which is a wire, so which we can physically see, which is actually carrying the signal. So since a wire is involved, we say this comes under wired communication. But however, depending on the frequency of signal, we choose a particular line, means transmission line. You cannot use a particular transmission line for all the frequencies, because in communications we have frequencies in the order of kilohertz, some signals in the order of megahertz, some signals in the order of gigahertz. So it is not justifiable to use a single medium or a particular type of cable for all the frequencies. If you try to use, you will face several drawbacks. In certain cases, the signal cannot even travel. So the choice of the transmission line is done appropriately according to the frequency of the signal that is being transmitted. For example, if you take a signal which is in the order of kilohertz, let us say 10 kilohertz, 50 kilohertz, 100 kilohertz, like that. If the frequencies are in the order of kilohertz signals, then we go for a particular type of transmission line which is known as twisted pair cable. A pair of lines will be there which are twisted against each other. So we say twisted pair cables. They are suitable to carry the signals which are in the order of kilohertz. What if you want to transmit the same information, same data with the same amplitude, but with a higher frequency? Then let us say in the order of megahertz. Instead of kilohertz, you are going for megahertz. The question is whether this cable works now? Absolutely not. You cannot use this. So then what we go for? If the frequencies are in the order of megahertz, then we go for what is called as coaxial cables or coaxial transmission line. So coaxial consists of an inner conductor. This is the axis of the conductor, and there is an outer conductor having the same axis, both conductors sharing the same axis. Inner conductor and outer conductor are sharing the same axis, so we say coaxis or coaxial transmission line. These are capable of handling signals in the order of megahertz. What if gigahertz? Then we have something called as waveguides. What if the frequency is even beyond that? Then we have what is called as optical fiber lines. Of course, that comes under optics. That's a different thing, but there is a type of transmission line because we are dealing in terms of frequency. I told that. So like that, the choice of the transmission line is strictly dependent on the frequency that you are using to transmit the signal. The study of these transmission lines will deal with, it has two units, unit 4 and unit 5. Fourth unit deals with transmission lines. Fifth unit deals with high frequency transmission lines. That means if you operate a transmission line at high frequencies, what would happen? What do you notice? What are the things that are going to happen? So in these transmission lines, you are interested in knowing what is the impedance of the transmission line, how do you go for impedance matching if there is any mismatch occurring, how do you mitigate that, how do you address that problem, impedance mismatching problem. Now when you transmit a signal in a line, primarily there are two things that will happen. There are several categories that we can discuss, but primarily there are two things that will happen. One, the strength of the signal gets, we say that as dissipation in a transmission line. Now dissipation is a drawback. Dissipation means losing the strength. A signal gets attenuated as it travels, which we say technically as dissipation, which happens when a signal travels along the transmission line. Now as an engineer, you should identify how to reduce the dissipation. What are the ways and means to address this challenge? Because if the signal gets severely dissipated, it may not travel the destination, it may not reach the destination. Even if it reaches the destination, the strength of signal is too weak, it's very weak to be demodulated, to be decoded. Then what is the use of signal? So the question is, no doubt the signal gets dissipated. Now what you can do as an engineer for the transmission line to see that the signal gets dissipated but to a lesser extent. Another problem that happens in a transmission line is what is called as distortion. Distortion means, suppose you transmit the signal, but what you receive? You receive the signal. The shape of the signal is lost. If the output is not the exact replica of input, then we say that as distortion. in terms of circuits, but this is in terms of lines. So, how do you define distortion? If the received signal is not the replica of the transmitted signal, shape out, that we say as distortion. Then in transmission lines, in 4th and 5th unit, we discuss in how many ways the signal gets distorted. That means what are the factors contributing for the signal distortion? What are the reasons? In how many ways the signal gets distorted? What are the solutions that we need to implement to reduce this distortion? If we are not able to totally eliminate distortion, at least you should try to minimize the distortion, make it very, very negligible. Now, all these things will be discussed in 4th and 5th unit and the study of transmission lines. Next, moving on to the overview of the subject. In the first 3 units, we are going to discuss electromagnetic fields. 3 chapters are dedicated for that. Now, the fields are broadly divided into 2 categories, namely static fields and dynamic fields. Well, you know, static means which do not change with time. That is why we also refer it as time invariant fields. Dynamic means which is completely opposite that. The fields change as a function of time. So, we say they are also referred as time varying fields. Now, the fields that are involved in wireless communications are not static fields, they are dynamic fields. If that is the case, what is the need to study the static fields? To make ourselves familiar with the fields, first we study the fields in their static form or in their simplest form, in their time invariant form. Then after understanding the framework, fields framework, then we develop our understanding for time varying fields. So, that is the reason first chapter you have electrostatics, study of static electric fields. Second chapter you have magnetostatics, study of static magnetic fields. Then we move on to 3rd unit, which is EM wave characteristics, the character or the behavior of electromagnetic waves as they propagate. So, this may not be the fields which are responsible for wireless communication, but they are helpful for us to make us familiar with the nature of these fields. And one basic distinction that exists between the static fields and dynamic fields is the interdependency. In static domain, or I can say if the fields are static, or if you are in static domain, the 2 fields E bar and H bar, the fields are independent. There is no relationship between E bar and H bar if you are in static domain, which means that if you write an equation mathematically, if you have an electric field variable in an equation, in the same equation you do not find magnetic field. That is the meaning of independent. Independent means E bar and H bar are independent. If you find H bar in an equation in the left hand side or right hand side, you will not find E bar in the same equation. If you find that, there is a relationship, that is a simple thing. If you find E bar and H bar in the same equation, left hand side, right hand side, which means that there is a relationship between them. But what I am saying, in static domain, or if you are dealing with static fields, E bar and H bar are independent. Whereas coming to the dynamic domain, that is the reason if you observe, here I have written E bar H bar, but here I have written E bar and I am using this symbol. What does this symbol mean? Time varying. So, these are time varying fields, these are time invariant. So, I am not using that symbol there. The symbol indicates time varying quantity. So, fields in dynamic domain or time varying fields are interdependent. Interdependent means they do not exist in isolation. One depends on the other mutually, which means if you write an equation, if you find electric field in the left hand side, you must find magnetic field in the right hand side and vice versa. That means if you find magnetic field in the left hand side, you have to find electric field in the right hand side, which means there exists a relationship, they are interdependent. That is the reason when you write Maxwell's equations for static fields, you do not find electric and magnetic fields in the same equation, you do not find, because they are independent. If you write the Maxwell's equations for time varying fields, you find electric and magnetic fields in the same equation. That is the meaning of independent. And the fields that are responsible for wireless communication are time varying fields, which are interdependent. So, we will continue in the next session.